Hi everyone, I'm Orta Therox, and this is Empathy at Scale, talking about how we manage the definitely typed repo. So I'm an engineer like everyone else. I have been using GitHub since the first year it came out, and have the prestige of being one of the few people that GitHub follows on Twitter. Um, I work on TypeScript, the programming language at Microsoft, and outside of that, I've worked on a few large-scale open source projects like CocoaPods, the dependency manager, Danger, the sort of rule verification system for pull requests, and Chicky 2 slash, a system for sort of providing interesting hover information and IDE tools in JavaScript code samples. And for this talk, the target audience for this talk is people that are interested in large-scale repo automation. And as TypeScript team, we're trying to be empathetic maintainers when we're working with community-led infrastructure, and we want to use automation to sort of respect their time and ours. And so this talk sort of covers the hows and whys with that, with a very small focus on the sort of technical details towards the end, in part because this talk is aimed about the ideas and not necessarily about the implementations. So to give you a sense of what we're going to do, we're going to talk a little bit about what definitely typed is and why it exists in the first place, how the repo works as a normal contribution process, then sort of talk about the system that we call the DT merge bot and how we document that so that people can kind of understand how it works. So to get started, we kind of have to understand TypeScript to understand definitely typed, but to understand TypeScript, you kind of have to understand JavaScript. So JavaScript is this sort of, it's like the English of programming languages. It's kind of used by everybody at some point in time, and it's estimated to be used by 50% of all programmers, which recently was said to be about 14 million people. And what we'll try and do to understand why TypeScript exists is to try and understand the most popular library for JavaScript, and that is jQuery. Traditional jQuery code looks a little bit like this. It is, just calling functions on objects. It's not too esoteric, but you can start to get a sense about sort of the problem domain that TypeScript tries to fix when you start to understand what the jQuery library looks like. So you write code like this, but jQuery's code actually ends up looking a bit like this. Right? When you distribute JavaScript code to web browsers, you tend to actually distribute a minified version of it that is almost a puzzle to try and read and understand as a human being. And even for a computer, it is easy to understand how it runs, but maybe not easy to understand how it is structured. And this is very reasonable for the problem of trying to run some code. But when you're working on code, you kind of want to have an experience a bit like this, right? You want to be able to have a tool tell you that the CSS function exists on this object. You want this way to be able to describe how this code works, but JavaScript, the language, does not have any sort of tools for doing that. And so, about 10-ish years ago, Microsoft looked at JavaScript and said, we're starting to build these really big projects in JavaScript, but we really want to have this way to sort of define the inputs and outputs of functions, define how all these objects connect, and in doing so created a programming language called TypeScript. And one of the parts of TypeScript that was needed to do this was a way to sort of declare things. So looking at the code we have here, right, we have to have a way to be able to say $1 exists. Like this identifier exists, and if you type $1 in, then that is actually something. You then need to be able to say that not only does that something exist, but it can be called like a function. And then say that, hey, you can actually put a string into this function, as well as being able to say, hey, the return value of that function is this thing, and this thing has further functions that can be called on it, right? We don't need to get into the sticks about all the raw details, but to give you a sense of what that looks like, this is the TypeScript definition code that would describe how that sort of code could exist. So TypeScript sort of has this way to make these declaration files to describe existing JavaScript code. And this is a very simplified version. This is actually the version for jQuery. It's two 13,000 lines long files. There are actually about 500 lines of source code and 2,500 lines of comments. And that actually talks a little bit to the sort of advantages of a system like Definitely Typed. Definitely Typed is this collection of ways to declare how these JavaScript libraries exist and how you can interact with them. And as you can see from this jQuery example, they're mostly about documentation. And to be honest, I don't think people really want, as the creators of jQuery, to be including 12,500 lines of documentation inside the version of jQuery that they ship to browsers, when it can be provided here in line in a way that editors can then use. And altogether, Definitely Typed is this one repo that consolidates about 8,000 different declaration sort of modules, like collections of definitions, into a single repo. And it is built in TypeScript. It kind of came from the TypeScript community, so that makes sense. It right now is about 3 million lines of actual code. It's about 8,000 odd NPM packages. We'll talk about that a little bit later. It has a lot of files and a lot of tests. They take about 30 minutes with 4 times concurrency, and it is a pretty old and mature code base at this point. So to understand the automation, we kind of need to have a better sense of how the repo is structured. So it's quite simple, actually. There is only really 2 main folders in the repo. One is scripts, which is largely unimportant, and then the other is types. And types is just a folder full of folders. There's about 8,000 of them, and they only really contain mainly 5 files. A thing that sets up TypeScript, a thing that sets up the node, a thing that sets up the definition, so that's like kind of the key point for each one, and then a tester for that definition, and then a linter. And we're going to have a quick dive into Alex's index.d.ts, so the sort of the main definition file for the library Alex. And this is what it looks like. It's very similar to the code that you saw earlier for my simplification version of jQuery, but you can see that it's got a lot of comments in it, and it's a little bit more complicated because it's real world code. But the one thing that I think is important to note here, especially for when we start talking about the automation, is that it includes a specially crafted comment at the top. And this comment includes sort of, it says its version, like its semantic version, but it importantly tells us which GitHub user has said that they are responsible for this library. In this case, that's only one person, but to go and take the one for jQuery, jQuery has so many that it scrolls off the bottom. And jQuery is a very popular library, and a lot of people are very invested in making sure it's high quality, its documentation is up to date, and that it stays and evolves both with TypeScript as new features are available in TypeScript to make sure that it's a really nice experience. And these are people that are taking their time to contribute to open source at quite a large scale for quite a large project. In fact, this is React, not jQuery. And both React and TypeScript are evolving quite fast, and these folks are pinged quite often by these systems to try and have them have the ability to maintain it themselves, and that is part of our goal here. So to give you a quick summary, just to make sure that you get it, there are lots of folders in types. Each folder in types sort of has all these project configs and definition files and tests. As a repo for contributing, it is absolutely vanilla. There is very little unique to working in this repo in comparison to almost any other repo on GitHub. You clone it, you set up the dependencies, you edit it, you run your tests, and then you push the changes back. In our case, here's an example for the last pull request to that library, the JavaScript library Alex. That got merged, we waited a little bit of time, and we create a package. So in this case, the sort of main dependency manager for JavaScript projects is called npm, and what TypeScript definitely type does is it generates an individual package for every sort of type definition under a unique namespace called @types. So this is @type/Alex, and so anybody in the Node and npm ecosystem basically knows that they can look to see if they have an @types/myLibrary name to see if that has type definitions available for it, if it does not include its own type definitions. And this is really useful for all sorts of editing tools to be able to reliably do a quick lookup on npm to sort of see it, almost treat it like a CDN to see whether the definition files exist for any particular JavaScript library. So quick summary, it's not that different from most repos. Once you make a change, it automatically deploys to npm. And so this brings us to sort of the meat of this talk, which is the system called DT-mergebot. And DT-mergebot sort of came quite naturally after hitting a certain scale. So today we have one TypeScript compiler engineer is on rotation working on definitely typed all the time. So you have an engineer that is like working on the TypeScript language most of the time, and then they sort of pluck themselves out and sort of maintain definitely typed for a week. And then on top of that, we have like very active community members who are constantly jumping between pull requests and helping people out. These folks have to then sort of work with about 20,000 contributors to definitely typed. It's a lot. And about 14,000 people have signed up to actually get notifications on the definitely typed repo. And that's not like the watch button. They went into some of those definition files and put their email address, their GitHub alias into those definition files, so that then they will get notifications when the sort of the smaller libraries that they care about change. And that's quite a difference in numbers, but it starts to become quite ridiculous when you take into account the amount of usage of the types. Like altogether, there is roughly roughly 1 billion downloads a week of these types. It estimates about 1,500 every single second are downloaded. Like in part, that's just the scale of the JavaScript ecosystem, but it also talks to like the importance of kind of making sure that you're getting it right most of the time, and especially at scale when you're talking like a library like jQuery or React. We want to make sure that like those are treated with a lot of reverence for the amount of impact every single change to definitely typed for those libraries has. And so we were sort of thinking, what ways can we as the TypeScript team and as definitely typed maintainers try to give people some of the responsibility that they want on some of the smaller dependencies in a way that we can sort of balance giving access rights to the sort of long-term health of the ecosystem. Because there's an awful lot of pull requests going to definitely type given the scale of it, and only having one engineer trying to keep on top of all of those pull requests and merging them, and also having the sort of difference in the engineers' timing approaches to definitely typed means that it's very unpredictable for contributors. But we started to feel like we had got our tooling on the repo to a certain state. We felt like we had got both our continuous integration system set up to a point where we were like really quite proud of it, and really at a point where we felt like most of the time as maintainers of the repo trying to decide whether to merge a pull request or not, we were mostly relying on the advice given to us by our automation. So, our CI was validating that every change didn't break its transitive dependencies, or and that people were making informed decisions about whether to make performance trade-offs or not. And that we were making sure that the code that people were shipping was like high quality, up to date with the latest versions of TypeScript and whatever their libraries were. And we felt like we had got to a point where we could start relying on that as being a very strong indicator about the safety and quality of an individual change. And so we created DT MergeBot. There was 3 of us involved in the process, Ellie Barishley, Ryan Kavanagh, and myself. And we have a GitHub repo. You can go see it if you want. We sort of tried to figure out what our key goals were with DT MergeBot ahead of time. We wanted to find a way to help get simple pull requests merged without us being in the way. We wanted to highlight how non-simple pull requests could get turned into a simple pull request. And we wanted to make sure that we had a way to triage the pull requests which were not considered simple at all, so that it would be quite obvious to a DT admin what they should be doing next and what they want to be looking at. So the way in which we did this was to start classifying out pull requests. First by looking at the existing ones and trying to decide which ones of these could be auto-merged if we had the tooling. And we sort of came up with these pretty simple rules. We said there was 8,000 different packages, so we want every pull request ideally to only change one. And so if one pull request changes one package and that package is not critically popular, with critical being over 5 million downloads a week or a month, but that it has test changes, the test pass, and that it has had a review from somebody who is already a domain expert in that library. So something that I haven't said that is kind of interesting here is that, like, as maintainers of Definitely Typed, we cannot know the intricate details of every single library on it. So we as maintainers cannot say whether that function actually exists in the JavaScript version without having to look it up ourselves and go and read the implementations. Whereas the people that are sending the pull request and reviewing the pull request, they know the libraries. They actually understand how to use it because they probably do use it. Whereas we as TypeScript maintainers don't. And so we want to find a way to give these people a way to sort of automate their own life. And we succeeded. It's been a year or two since it came out, and at this point now about 50% of all pull requests are self-merged. And this is really great. So to give you an example, I plucked a recent pull request, and this one went through in an hour. So it was a PR to IO Redis, and the first thing that you see here is that a bot automatically responds. We'll go into detail about how and why this message is structured the way it is later, but the response first tells you the sort of status, and then it pings everybody that says they're interested in this particular library. And in this case, almost instantly, like within the hour, somebody came and said, hey, I see these changes are good, I'm going to give it a green review, and the bot responds instantly and says, okay, great, thank you for accepting this change. I'm ready to merge if someone explicitly says we can merge. And then within the rest of the hour, the original poster for this pull request comes back and says, good, ready to merge, and that was it. So that entire process took somewhere about an hour. It had the original creator submitted it, all the tests passed. There was no performance regressions, so that didn't show up. We pinged the people that said that they're interested in this. One of those people said it was a good change, and then anybody involved had the chance to merge that pull request. And that was sort of our goal, actually. This is like exactly how we thought about it in our heads when we first started mapping out what this process could look like. It was only actually a little bit later down the line when we started to mature the system that we realized that we had to be a little bit more deliberate about something else, which was trying to figure out the times in which there are downtimes between those reviews, right? In those cases, the humans instantly responded, but realistically, that's it's not very rarely the case, but there's a lot of times when the humans don't respond. And so we had to spend quite a lot of time trying to think about how do we map these times where somebody doesn't respond, and there's many reasons why someone doesn't respond. Like, it could be that they are just busy, but it could also be that somebody's change is a bit too controversial for anybody to individually say, I'm gonna go out of my way and be like, this change is okay. And so we sort of derived this sort of freshness concept based on activity like comments, git commits, to try and keep people engaged in that pull request, or at least explicitly say, hey, we're about to move from this being an active pull request to being one that's considered stale. And if it is, you might just want to consider closing it, to try and like encourage people to actually do something. But in the end, we sort of have this system of escalation. If nobody who truly understands that library has given any feedback, then we pass it up to the TypeScript team, and we will try and take a look ourselves. And eventually, if the TypeScript team gives some feedback and that never happens, then we'll eventually let these idle pull requests get closed. So one of the main ways in which this PR system gets documented is effectively by the communication of the comment. This is the main comment, and what we tried to do was to try and make sure that there was just one main comment. This comment is sort of highly structured in how we have addressed certain problems. The first bit is we want to give feedback straight away with what the bot thinks has happened. So in this case, we're looking at a pull request that has edited a dependency called require.js, and we provide links to that for people wanting to review it. Then we've sort of looked at who is responsible for the next step. So, in this case, this pull request goes directly to the maintainers of definitely typed, because require.js is, because this pull request doesn't have tests. And we make it very explicit here by saying like, you can't actually do anything to move this at this point, except when we go into the next section where it's always trying to give you an overview of what is happening. So this pull request is not on the golden path to getting self-merged because it does not have tests. And we use this status section down here as a series of checklists to make it like quite obvious about what is the next thing that you can do to, in this case, to unblock requiring a DT maintainer. And you'll see in a second that we also have a second comment specifically to call that out and give links and context into how that works. And we repeat ourselves, right? You can see here that we say, hey, it's reviewed by a DT maintainer, but only a DT maintainer can do it. And we felt like it was an important aspect of specifically this comment, this main comment that's trying to give you as much information as possible, to actually repeat ourselves, because when we did this, we found that we got a lot more people responding to the bot and actually making the change here, like in this case specifically trying to encourage more people to add tests to their changes, and that has helped quite a lot. The other part that I'll show next is sort of the way in which we create other comments. So these were the other comments that would have been posted onto that original pull request. The first one is a very explicit, hey, author, your PR didn't modify any tests. And one of the key things to think about how we did the text for these is that we tried to make sure that the person's name is first, and that the action that they do is also within that first sentence. If you think of it as like, they're going to receive an email or a notification of some sort that only contains one sentence worth of information. We'd like that one sentence worth of information to say, it's specifically to you, and this is the thing that you need to do. And then after that, we can have all the context. So a comment like this really sort of encourages people to get back onto the golden path of being able to self-merge. And the comment for a review is very explicitly, hey, Jay Baldwin, please review this PR. And again, if it doesn't get reviewed by them, then it moves back to the definitely typed maintainers and the TypeScript team. But we would like for people to be able to self-merge because, it gives them control over the things that they care And in the process, it actually also tells them why it is worth doing that, right? Like, this can potentially save days of time for you is true, and TypeScript team and the DT maintainers have to go through a lot of PRs before they will probably get to one that came out today. From the issue, we also started applying labels. So when I said that we, the TypeScript team and DT maintainers would mostly rely on the results of the CI to give us information about whether something is mergeable or not straight away, that's based on our label system. We tried to define sets of labels that would give you enough context going into a pull request to then be able to almost know straight away whether it's going to be an easy one or a hard one to do. That can make it easier for you when you're an admin running over many different pull requests in a day. But also it makes it very easy for the PR owner to know what sort of status their pull request is in. Specifically, we have a lot of the CI is failing in this case, and unless they've specifically asked the question, that means it will basically get ignored until somebody has come by and it has been triaged into a DT maintainer's to-do list, which on that to-do list is done by GitHub projects. We have the bot sort of try and define a priority system for looking at these issues. In part, that's just based on time and how blocked it is on a TypeScript and DT maintainer. So if it could possibly be self-merged, then it stays in further to the right. If it's something that only someone from the DT maintainers team can do, then we try and move it as far left as possible, which means when you're triaging, you start on the left and then you make your way right. And this makes it very easy for us to look at the entire set of open pull requests. There's usually about 100 open at any point, and have a sense of which ones we think are important for us, the team, to deal with. So at this second, that's about 9 plus 12, so somewhere around 20. And then there's 80 odd pull requests that aren't necessarily things that we have to deal with, and people could be just pinging and chatting with us about them in Discord or in the GitHub issues if it's important. We found that we were sort of struggling with this strange problem of we had a repo that represented about 8,000 separate projects, and what that did was it created a lot of GitHub issues that the people that created them did not have any ability to sort of close themselves or to sort of maintain themselves. And so when GitHub discussions came out, we migrated any discussions about individual projects indefinitely typed to GitHub discussions. And to sort of do that, we kind of used tooling from the DT merge bot to really encourage people in this direction. When we switched to discussions, we closed about 3,000 GitHub issues. What we did was we tried to help people make issues that were structured in some way, discussions that were structured in some way. So then we could provide tooling like, pinging the same people as we would have done in a pull request. In this case, somebody asked a question about a particular dependency, we pinged the people that are involved, and one of those people sent a pull request and fixed it, and then it was marked as done. It's the perfect workflow, and exactly the sort of thing that we could only have done with GitHub discussions. We could have done it with issues with a lot more automation behind the scenes, but this felt like a nice mix of sort of, Stack Overflow style voting and chatting versus issues, which is very much oriented towards something very actionable. From there, we had the problem of how do you document that to the world. And we sort of think of it as there's main three angles in which we document. There's documentation from the sense of the system is self-documenting because the comments is built to sort of teach you how to use the system. And so our initial documentation tried to talk a lot about the hows and whys we built the system, and to give people an overview of what to expect as we built it out. And then once we had built that, we started, building out the user documentation. And one of the best bits of our documentation, I think, is this flow diagram. We found it took like a lot of simple things. It took a lot of refining to get to this stage, but I think it shows quite well the sort of golden path that you could take, as well as all the different ways in which your pull request could go off that golden path, and what sort of timings to expect from inactivity and the staleness that we talked about earlier. How did we build it? Well, as I said, we're not going to talk too deeply about it, but we're the TypeScript team, so it's built in TypeScript. We used Node and we used Azure Function Apps. It was really great. The way it's structured is kind of interesting in that we have the redundancy. GitHub webhooks come to our Azure Function App, but at the same time, we also run GitHub Actions every 6 hours that will run the bot against all open PRs. And sometimes we don't notice that either one of those has gone down because the other one is covering it so well. The internals of the system is basically a two-step process. We first sort of generate this GraphQL query, and then from that query, we then create this kind of derived data that sort of summarizes the issue from the perspective of the bot. And then that bot makes comments in the pull request or issues. We found that one of the ways that made it easier for us as DT maintainers to sort of conceptualize what the bot actually is thinking is to actually include this diagnostic information in every single main comment on a pull request. So we can always see what the bot understood of this pull request in order to see if that compares with the actual pull request itself. And so that was a rough coverage of the definitely typed automation system that we have around that repo. Again, it's one of the biggest and most active repos on GitHub. This system is built to try and empower individual contributors in ways that they don't have to rely on the TypeScript team to do a lot of the work for them. They get to self-merge about 50% of those pull requests. A good chunk of them are done in under an hour, and for an open source project, that's a really fast turnaround. And then within half an hour of that being merged, their changes are available for them to see. And right now it's October, which means it's Hacktoberfest, and we are getting a lot of pull requests for people's first ever open source commits. And this happens every year, and it's really cool. So thank you. I'm Orta, and I hope you have a good universe. Bye.